Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our student course registration system. And particularly, we're going to focus now on some of the functions inside of our static array library. In this case, we're going to look at our import students and how it relates to the underlying data structures that we're wanting to use, particularly our student type. This video assumes that you have watched the earlier videos on setting up our student course registration system demo, as well as having obtained a copy of the appropriate .h files and have started on your StaticArray.c. In addition, it also assumes that you have obtained a copy of our students.csv, our courses.csv, and our registrations.csv. Now I've went ahead and taken the extra step of putting it in the folder with our executable because as we develop this application, we want to be able to test it. And in order to do so, we have to have access to those CSV files. Additionally, before you forget, I would encourage you to go ahead and copy these three .csv files up to the base directory for our project, so that they can also be available for when you are debugging. Now, don't be alarmed at the number of .h and .c files I have here, as I am planning on working through multiple demos associated with this project. So to begin with, like I said, make sure that you have obtained a copy of those .csv files and put them in your MinGW compile directory. Now, what we'd like to do is we'd like to see about the relationship or understand the relationship between each one of these files and their corresponding data type. And specifically, we'll start with our student type, and you'll notice that it corresponds to the columns in the .csv file. Just to remind everyone, the .csv file stands for comma separated values, in the file itself can be created in Notepad pretty easily. The first column corresponds to the student status enum. This status enum is used universally in our system, and at the very beginning has three states. We may add to that later: unknown, active, and inactive. 0 basically means that the status of the student is unknown in our system. If it is 1, it corresponds to active, and if it's 2, it's inactive. And we can add to this enum as our system evolves, but currently we're going to use these three states not only for our student, but for our course and for our registration. Now, what does it mean to be an unknown or an inactive student? That just simply means that you are not going to be eligible for registration in a course. So only an active student can actually register for a course. Likewise, what does it mean to be an active course? Well, that just simply means a course that can actually be registered for. And lastly, what does it mean to be an active registration? Well, that just simply means that a student is, in fact, currently enrolled in the course, hasn't dropped, hasn't withdrawn, and so on. So what we're going to do is we're going to focus on this video on the students.csv. And particularly, you'll notice the order of the fields, starting with the student status, the student ID, first name, middle initial, and last name. And also, please note that we are limiting the middle initial to 1 character plus that end of string character. We could have simply done it with a single character, but this just keeps those data fields consistent. In this case, they are all strings. The other thing that you want to do is make sure early on that any of your columns in your CSV file do not contain commas, and also the lengths are appropriate. So in this particular case, you just want to quickly check to make sure none of your names are longer than the space allocated for each one of your fields. And keep in mind that you always want to have an extra character for that end of string character. Now, what we want to do is we want to go back to our .c file and to our import students. We're also going to need to use our .c file, our core.c file, and our core.h file in this particular example as well, as we are going to need to verify that we have valid input arguments to our function. So to begin with, we want to think about what this import students function is going to do. And you can imagine that what it's going to do is open up this .csv file, and it's going to read in the contents of the CSV file, splitting it by commas, and ultimately updating this students array with in this case, 5 students. And it will update the count so that the calling function can see the number of students that were successfully imported. It will then return the value of exit success or exit failure, depending on the logic that we put in our function. So let's get started with this. First thing that we'll want to do is flush out some temporary variables. Now, we may not get all of these right in the beginning, so we'll probably need to go back and add a few as we go along. But at the very least, we know that we're going to be dealing with a file, so we might as well create an input file pointer. If we are reading from a file, particularly if we are going to be reading lines out of a file, probably should go ahead and create a line variable. And what we're going to do is we're going to use our line length max from our core.h constant to dictate how long the longest line is that we are going to read. And I think you can quickly see that 1,000 characters is much, much longer than we will be using for our students.csv file or for any of our other CSV files. So you want to keep in mind that sometimes you probably want to go back and revise some of these constants. Continuing on here, we also know that if we're going to read our students.csv file line by line, we ultimately want to split it into chunks, in which case we want to go ahead and create a 2-dimensional array, with the first dimension being the maximum number of chunks, or the chunk count max, and the length of each chunk being chunk length max. And once again, these constants are in our core.h. And you'll see that this results in a very, very large array, our very large chunks array, where we could have possibly 20 columns in our CSV file, each column being 1,000 characters in length. Now, why do we have such a long chunk length? Well, in the situation or in the case in which we actually don't split the line, we have to make sure that the chunk is large enough to store the entire line. The key is here, you would want to modify these once you understood your individual problem better. So these are much, much larger than what we would practically need, and we would probably want to consider making them smaller. Now, let's jump into the rest of our code here, and let's begin with initializing some of our values. And particularly what we want to do is we want to initialize the count. We are going to make the assumption that we are overriding anything that is in our students array with the students from the file. Once again, if your system has some other requirements, then maybe appending to an array, you would consider not doing this. At this point, what we want to do is do some basic validation of our input arguments. Specifically, what we want to do is make sure that our file name is in fact not equal to null and at least some sort of minimum length, and ideally also has the .csv file extension. This is where another feature in our core.h is relevant, specifically our string find function that we wrote earlier in our core demo. What we want to do is we want to verify that the file name is not null. We also want to verify that it is of a certain length, and that it contains the .csv file extension. We don't necessarily care about the name, although for the project's sake, we would want to keep the CSV file as students.csv. So let's go ahead and get started. Remember that we want to write our validation logic in such a way that it checks to see if, in fact, the case that we are looking for exists. So in this particular case, what we want to do is first check to see if our file name is equal to null, or our file name, we can use our string length function. We have to set now a minimum length for our file name. And if you were to use the .csv file extension, that would automatically consume 4 characters, which means that you had to have at least a 5th character to have a valid .csv file name for our function. So in this case, if our string length was less than or equal to 4, there would be a problem. Or you could also, if you'd like, just simply have this be less than 5. And then the or as our third condition that we wish to check would be whether our string find function fails to find in the file name the .csv file extension. Now, the way we wrote this function, we will also require a locations variable. We aren't going to necessarily be worried about that. As a matter of fact, we're just simply going to dispose of the value here, but we still need to provide that variable name. But more importantly, what you want to do is navigate to your declaration of your string find function and remind yourself of what the return value is. And in this case, the return value is the count or the number of matches. And in this case, we're hoping to find exactly 1 match for the .csv file extension in the file name. So what we want to do here is write this in such a way that it is not equal to 1. And if any of these 3 scenarios are true, then we simply want to print out a message back to the user that says error, invalid, file name, followed by a new line. And then most importantly, what we want to do is we want to say results equal to exit failure. At this point, we want to take just a second to go ahead and create a integer locations array. And once again, we wouldn't expect it to be that large, so we can just simply put a default value in here of maybe 2 or 3 or 10. But basically, that would mean that it found 10 copies of the .csv file extension. So you could just simply leave it to chance and put 1 here. If a user did provide a file name that had .csv.csv in it, then it would actually cause your application to crash potentially. So what we do now is under our else if, we want to do some additional validation here, and that is going to be on our students array. And at the very least, what we can do is we can check to see if our students are equal to null, and in which case we would want to simply printf a message back to the user, error, invalid students array provided. And once again, since we aren't dealing with dynamic memory allocation for this library, there's not really a whole lot we can do other than simply saying results equal to exit failure. Now, if we have successfully managed to avoid those 2 statements, that if statement and then that else if statement, at least we've done some cursory validation. At this point, what we can do is jump into opening the file. So in this case, we're going to use our fopen. And we still may not have a file, a valid file, but at least we can attempt to open it, at which point we will follow that up with a check of the input file pointer. And if it is not equal to null, we can proceed in reading from it. Else, we have a printf and error unable to open %s and provide then the user the file name that was attempted to be opened. Now, once again, we want to say results equal to exit failure. And then if you want to, you can reverse the logic here in such a way that we only traverse the true branches of the if statement, or rather only traverse the false branches of the if statement consistently. Notice how I've sort of reversed my logic here. In the earlier stages in the validation, I was looking for conditions that we would want to eliminate. And in this particular case, now what I'm doing is I'm looking for the condition of where we have been able to successfully open the file. Once again, it's up to you if you want to flip this logic. Now, assuming then that the input file is not equal to null, before we go any further, we always want to remember to go ahead and close our input file, because that's very easily forgotten, or rather our input file pointer. And what we want to do now is we want to leverage one of our other functions from our core.h, and that is our file read line. And notice that our file read line accepts a pointer to an open file as well as a line character vector. So what we can do now is we can use a while loop, and while file read line, and we pass to it our input file pointer as well as our line, while it returns something greater than 0. In other words, while it's been successful at reading something out of the file, we now want to attempt to parse the line. Well, once again, we can leverage one of our functions that we have written in our core.h, specifically our string split function. And if you recall, we want to be able to split one of our lines based on a comma. So what we'll do now is we will set up an if statement that utilizes our string split function. And we want to split each line by the delimiter, in this case, a comma, and we want to then store those chunks in our chunks variable. And specifically, we are only interested in the scenario in which our string split function returns 5 values. And why 5 values? Well, there happens to be 1, 2, 3, 4, 5 values, or 5 columns in each row. Any other scenario then should at least prompt the user with a warning. So in this case, printf, warning, invalid line in the input file. Now, we could go so far as to capture this return value from our string split function and also provide it to the user. It's completely up to you. You could also provide the line to the user. In this case, what we can do is simply put the %s here and provide the line in its entirety. And that's fine for files that have shorter lines, but as the lines get longer in the file, that output to the user could get a little messy. In this particular case, we probably don't want to set results equal to exit failure because the entire function has not failed. It simply was unable to read a single line. At this point, what we need to do is update our students array. And specifically what we want to do now is we want to update a particular student that is going to be referenced by our count variable, or think of this as an index. And what we can do now is we can start with that first column. And that first column is an integer, but remember that in the CSV file, it is nothing more than the character 0 or the glyph 0. Instead, we want to store this in our array as an integer, or in this case, as the enum student status. In order to be able to accomplish this, what we need to do is we need to convert that character into the corresponding integer using our a to I function. So what we'll do now is we'll say a to I, converting our chunks, square brackets, 0. We also want to copy each one of the columns in the CSV file to the corresponding field in the structure. And we'd love to be able to do something like this: students star count dot student ID is equal to chunks, square brackets, 1. But unfortunately, C won't let us do this. Instead, what we want to do is we want to use a string copy function, and our string copy function will allow for us then to copy to the destination from the source. In this case, the source is going to be the specific column out of that particular line. In this case, chunks, square brackets, 1 corresponds to the student ID. You can simply copy and paste, changing the field names. In this case, it's going to be dot first name corresponding to chunks, square brackets, 2, dot middle initial corresponding to chunks, square brackets, 3, and last name corresponding to chunks, square brackets, 4. Now, before we leave this, we have 2 things to point out. We need to increment our count. We also want to consider validating some of our information here. Specifically, what we want to do is look at the return value from our a to I function, and note that the a to I function returns 0 if it receives a value as an input argument that it cannot parse as an integer. And in this particular case, that is actually what we would want to have happen, because if you recall, a 0 in our student course registration system.h corresponds to the unknown status enum. So in other words, if somehow some garbage got into our CSV file where it couldn't parse it correctly as an integer, it would simply return 0, and ultimately the student status would be unknown. We probably also want to consider checking that the chunks, square brackets, 1 is in fact greater than 0, or rather the length of that chunk is greater than 0, as well as the length of the first name. The length of the middle initial can of course be 0, but the length of the last name should also be greater than 0. So we're not going to cover that in this particular video, but what I am going to do is make a couple of notes here, specifically that a to I will return 0, or in our case, unknown, if it is unable to parse chunks, square brackets, 0. And also that we want to verify or validate chunks, square brackets 1, chunks, square brackets 2, and chunks, square brackets 4 to be greater than 0, or to have a length greater than 0. So we would want to do that before we ultimately inserted those values into the array. We'll come back and clean that up later. At this point, we're pretty much done with this function. And so what I'd like for you to do is go ahead and build it, make sure that we don't have any problems. And if you'll notice here, we're getting a warning here. And specifically what we're getting here is that we've got actually an error and a warning here. Number one is we failed to specify the method in which we want to open our open our file, what kind of access we wanted. And then secondly, we're getting a warning that corresponds to our string copy, in which case the way we get around this one is we simply include string.h as a library because it contains our string copy function. At this point, let's see what other errors we have quickly. So we have warning. So we have an error here. We just need to handle our string split function actually accepts a single character. So we need to change our double quotes to single quotes on our string split. But then the warning here on our string find function can, at least for right now, be ignored. It stems from the fact that we are passing our file name as a constant string or a constant character vector. And in our core.h, we have not specified that it would be constant. So we probably want to go back and modify our core.h just to remedy this situation and make sure that the contents variable can't be changed. At this point, though, you can go ahead and build it, and we should only get warnings. If we rebuild it one more time, we should be ignoring those warnings. And at this point, we should have working code. At this point, what we'll do is we will follow up in another video demonstrating how we can display the array that we have successfully imported. And we will also focus in on some of our other functions. Hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to email me, and thank you for watching.